Welcome back. So in this lesson, we're going to take a closer look at Perlin Noise, and we're going to use the noise to animate a line. Then we'll turn this moving line into a drawing machine of sorts. And then we'll build on this afterwards for this week's code exercise. So let's get started. So we're going to start by remixing our blank app, as we typically do. And we're going to call... We'll let this program start here. We're going to call this sketch, let's call it dancing line. Animating a line with Perlin Noise. Awesome. So let's go into our sketch. We are going to show the result next to the code. Use a black background and get rid of this circle. All right. So in this example, we're going to look at using Perlin Noise for animation. So just to get us started, the first thing we'll do is we're going to create a variable, and we're going to use noise to set this variable. We're going to call it x. It's going to be an x position of a point. And as we've learned in the previous video, we need to give noise a parameter. So in this case, we're going to use frame count, and we are going to divide frame count by some amount so we're not moving too fast. So let's make an object called settings. And inside this object, we're going to put a variable called res, and we'll set this to 0.01. And we'll add our GUI in a second as well, so we can play with the value of that variable. Now, just for now, we're going to set y to just half the height of the window, and we're going to draw a point at xy. We'll set a white stroke, and maybe we'll make this stroke a little bigger so we can see what we're doing. This should be a comma. I always forget. I always put a semicolon there instead. Okay, so now we have a noise value that we're assigning to x. Now, it's important to remember noise is always going to return a number between 0 and 1. So we're going to multiply this by width to scale it to fit the entire canvas window. So now what we have is we're animating this point using Perlin Noise to set the x coordinate. It would be nice to be able to experiment with the res here to change how quickly we're moving through this Perlin Noise space. So let's bring our GUI in as well. So GUI, we're going to use the .GUI library, which we introduced in the previous lesson. And then we're going to add the settings object to be controlled by our library, the res parameter, and we're going to go from 0.01, quite small, to maybe 0.2 as our range. We can always change it later if we feel like it's not interesting. Actually, 0.2 might be even too much. Okay. So already this is moving pretty fast, and then if I move the slider to the right, what this res variable is doing, remember, is dividing frame count so that we're not jumping as quickly through the noise space. And if we make this a really tiny value, now our circle is moving much slower. We have a random motion here, but because it's controlled by the Perlin Noise, it's also more natural than if we just made it completely random, where it would just jump all over the place. It would be nice now to be able to animate this point in 2 dimensions, not just along the x-axis. So one way that we can do this is we can just sample the noise just at a different spot, right? At a different point further down the road by adding an offset. And here's what I mean by that. So we're going to make y equal to, so the same thing here. I'm going to copy and paste. Okay. So we're going to make y equals the same thing, except here we're going to multiply by height in case we don't have a square canvas. Now notice if I do this, my point is now moving along a diagonal, right? That's because these two values are the same. Remember, Perlin Noise, once you start your program, the value you get out of noise is going to be predictable. So if you give it a number as the input, you're always going to get the same value back as the output, unless you stop the program and then start it again. What happens then is noise gets a brand new seed at the beginning, and then it'll generate a new set of random values. So frame count, right, times setting.res is always going to return the same number. So if we use that same input twice, we just get the same number, hence the diagonal. So what we can do is if we want to get a different random number, but that is controlled by the same noise function, we can just say the y value is going to come just further down the line. We're going to sample just arbitrarily. I just added 100 here out of the blue. We're going to just move further down this noise landscape, and we're going to sample a point that is 100 values away from the one we're using for the x variable. And the result is now we have this little point that's animated in 2-dimension. And it has, I think, like a very interesting behavior that is 100% because of the nature of the Perlin noise. So it's moving in this unpredictable fashion, but it's still kind of organic. And we can trace the path of this point if we wanted to, if we play around with where we put our background. So I'm going to comment out the background here, just so we can see it move over time. It's a good idea to point out, I put background here in both of these functions, in window resize, and in setup, because setup runs once in the beginning, and window resize runs whenever I change the size of my window. So if I'm going to clear the background, I also want to do it in here as well. All right. Okay, so now we've used Perlin Noise to create a simple little animation. We're moving a point around, and we can control the amount, the resolution of our noise, which is like how fine of a movement do we have within that noise space. Okay. So the next thing we're going to do, we're going to add a second point to this, because eventually we want to be able to animate a line using Perlin Noise. So if this is our first point, we're going to have 2 points now. So we're going to call this one x1, y1. And the second point, we're just going to copy and paste, save some typing. And this one we're going to call x2, y2. Now, again, these are going to be identical. They're going to be the same unless we sample from a different place in the noise landscape. So just like we did for the y value here, we're going to add some arbitrary offsets to these new values we want to get. So now we're extracting 4 different numbers from the noise function, right? All in different places along that landscape. All of them follow frame count and the same resolution, so they're sort of moving at the same pace. They're just moving independently from one another. Let's bring the background back so we can see them moving. So now we have these 2 points moving. They're both controlled by noise. They're not really following each other, but it kind of looks like they have this interesting behavior because of what noise is doing. So if we wanted to, we could connect these points with a line, for example. We could say, let's draw a line from x1, y1 to x2, y2. Okay. So just for fun here, we're gonna add a little bit of transparency to our line, because if we remove the background, for instance, we can see now it's doing a pattern, but it's a bit hard to see because we have a fully opaque white line. So let's add another settings to this program. We're going to make this setting tweakable using our interface. I'm going to call it alpha for the alpha value or transparency. And we're going to tell our GUI we've added a setting called alpha, and that's going to go from, let's say, 5 to 255. And then when we set the stroke color, we're going to say 255, settings dot alpha. So that's going to set a white stroke with some degree of transparency, and we can control it using our setting over here. And maybe we'll get back to a normal, not normal, but a stroke weight of 1 for this example. And then these 2 points here, I'm going to get rid of them. They're kind of redundant for now. Okay. We can play with this a little bit. We can have slightly transparent line, or we can have just a fully opaque line, so just for fun. Okay. So we're going to build on this idea of our moving line here a little bit more. That's going to become our framework in today's lesson to create a drawing machine. We've already kind of started doing that. So our line, we can think of it as, it's like a pencil or a pen on canvas that's creating a drawing for us based on the movement of these 2 points. The drawing is random, and then we control some of the parameters of that drawing. Now, one thing that we're doing here is we're using, or we're not using, background in draw in order to see the drawing build up over time. If I put background back in, right, all we see is this moving line. And this is a nice trick. Like we've seen here, we can get some interesting results by omitting background. However, it's also a bit of a limited trick, because as the sketch runs, this image is going to start to get more and more dense, and maybe it is what we want to achieve. But if I leave this to run for half an hour and come back, there's not going to be much to see there, just probably a whole bundle of white. So we're going to introduce a new trick in today's lesson where we're going to create this trailing effect, but we're going to create it by leaving the background on. We're going to clear the background, and instead what we're going to do is we're going to record the motion of this line. We're going to save where it's been, and in every frame we're going to redraw its path. And the reason we're going to do this is because we're going to have control on how long of a sequence we want to record. So if we want to, we'll be able to record some really short sequences to have short trails, or we can record extremely long sequences and have really long trails, similar to this trick where we remove the background. All right, so let's create a little recorder for our points. Now the values we want to record here are these 4 numbers that we're generating from the noise function, right? Our 2 pairs of coordinates. We want to have a place where we can say, let's save the numbers that we generated, so that from frame to frame we can kind of create a replay of what's been happening over time, rather than only be able to draw in the moment that one value that we're generating. So to create this recorder, we're going to build an array. We're going to call it recorder. It's going to be just an empty array, and then we're going to push on some objects into this array in every frame. So we're going to create an object here. We're going to call it a frame. So just like we're using the object syntax up here for our settings, right? In JavaScript, basic objects are just this. They're just containers for data, for variables. So here we have a settings object that contains res and alpha. Here we're going to create a frame object. And inside this object, we're going to put these 4 values. Now this is going to be a little bit confusing, because we're going to say the variable name, we're going to call it x1. Its value is going to be the variable x1 we just created over here. So this is going to be the name of the variable inside the object, and we're setting its value to x1. So we're using the same name, just because I can't think of a better name for x1 and y1 here. So we're going to put y1, x2, and y2. So what we're doing with this this frame object is we're creating like a little bundle here. And inside this bundle we have 4 values, right? We have x1, y1, x2, y2, and those are the values we just generated. Then we're going to say, okay, we'll take our recorder array and add this recorded frame to the end. and we're going to use the push function to do that. So push just takes an object and then it just adds it to the end of the array. So we started empty over here, and as time goes on, we're going to just add some more frames. Now, this line of code here is only ever drawing the current values, right, in the moment. So what we want to do instead is we want to write some code that's going to go through all the recorded values, all the frames that we've pushed onto this array, and then play them back over time. So because this code it has a defined sort of role, a defined function, I could write it just right here and draw, but just matter of preference. We're going to refactor this. We're going to put it into a function. We're going to create a function called playback. I'm just deciding to do that just so I can break the program up a little bit into smaller pieces. And after we've recorded, right, we're going to call playback at the end of draw. And now the job of this playback function is going to be to go through the array of recorded frames and then redraw all the things that have been happening. So to go through array elements, we have a few ways to do it in JavaScript. We can use a for loop, right? We could count like this using an index, right? But because in this case, we're not really interested in the index, we just want to go through all the frames that we saved. We're going to use a shorthand syntax. We're going to say for, let's call it frame of recorder. And then at each frame, at each step of the way, let's draw our line. So we'll say line. Now we're going to say frame.x1, frame.y1, frame.x2, frame.y2. All right. So let's recap what's happening here. So in draw, we're generating 4 numbers from the noise function. Then we're putting these 4 numbers inside an object called frame, and then we have x1, y1, x2, y2. Then we add that object into our array called recorder. Then we call our function playback. And inside playback, what we do is we go through every frame of this recorder, and then we just draw a line. Now, as it stands, we've kind of accomplished nothing because we're going to continue to add frames forever. So we're back to where we started. If we leave this running for a while, it's just going to keep drawing the same thing. So let's add a parameter to control this. We're going to call this parameter n frames for number of frames. And let's start with 50. And we're going to make this available on our GUI, n frames. And let's say we'll go from anywhere from 5 to 500. So now we have this value we can change. And what we're going to do is we're going to use n frames to constrain the size of this recorder array so that we can not record more frames than this number, whatever it is. Let's say like 57 right now. So for example, we could write something like this. We're going to say if recorder.length, right, is greater than settings.n frames. What we want to do is we want to remove a value from the recorder array. Now there's a function on the in JavaScript with arrays. If you want to remove the oldest value, like the first value you've put in the array, the one at index 0, you can do shift. So shift, it removes the oldest value. Okay. So push adds to the end, and then shift, basically it shifts the whole array forward, and then it deletes the oldest value. So if we do this, you can see now that we're on this side, we only have up to 50 frames that we've recorded, right? So we've saved the position of our line for 50 frames, and then playback is running through this array and then drawing the entire sequence in every frame. And that's nice because we can have background here, right? And we can still do like some layering effects over time with the alpha value and so forth. We just now have more control over this. We don't have to just let the trail go on forever. we could also draw other elements in there that wouldn't be affected by this trailing effect. So this is kind of nice. Now, there's one small issue with our code here. This is going to work if we increase the size of the number of frames. Now, all of a sudden, we can record more frames, and we can see the trail getting longer, right? And we can affect the change of alpha in the entire trail. But if we try to go the other way around, we're going to have an issue. It's not going to work. So if I lower this number, right? Notice I want to have 5 frames, but my sequence is not shrinking. And that's because our code does not account for this. It just says if we have more frames, just remove 1. But we also just add 1 in every frame. So if we shrink the number of frames available, this code here will just never catch up. It will only ever remove 1 frame from the array. So we're going to do a small tweak to make it work. Instead of an if here, we're going to replace it with a while statement. And now, if you don't remember what while is a form of loop that works very much like an if. It says as long as something is true, all right, as long as this condition is true, do something. It's our basic form of the loop here that we sometimes use. Most of the times we'll use for loops, but this is an example where a while loop is useful because we don't know how many extra frames we have. We just know that we want to keep removing frames from the beginning of the list until we reach our limit. So having done this change now, I can increase the number of frames and my trail will grow accordingly. And I can do the opposite. I can also make this number smaller, and this while loop will just get rid of all the excess, all the dead weight using recorder.shift until this condition is met. So with while loops, you have to be a little bit careful because it's easier to create an infinite loop setting. But in this case, there is no risk of that happening because the number of frames, because we are constantly adding frames to the array, and eventually we don't set the number of frames to 0, for example. So we're not going to get stuck in some infinite loop. All right. So before we move on, this sort of dancing line example here, it's going to serve as the framework for this week's code exercise. We're going to build on this a little bit, but I want to talk about an important concept here with generative systems, which is that a lot of the times when you're working generatively, what you're going to want to be doing is creating a framework for yourself and then mapping something different onto that framework. So what I mean by this is that essentially a framework here is these 2 moving points. We have frame.x1, frame.y1, and then we have point frame.x2, frame.y2. Okay. And they might be hard to see, so let's make the stroke weight a little bit bigger while I explain this. So this is the framework we've created for ourselves. We have these 2 moving points animated by noise, and we also record their trail of motion using our recorder array. And from this point, from this state here, we can sort of imagine so many different ways we could map a drawing system on top of these values. Right? The simplest one being what we've tried to do so far. What we've done so far, which is to say, just draw a line between them, right? Let's emphasize this with the stroke weight a little bit more, right? So now we can clearly see the endpoints. So one way we could interpret this this framework is saying, okay, we're going to connect the dots. We're going to draw a line between these points. But ultimately, these are just changing values. There's lots of other ways we can interpret them, or lots of other ways that we could choose to represent these quantities. So let's try to come up with one other version, one other way we could interpret this drawing machine without really changing the basic framework underneath. Okay? And that's kind of similar in spirit to the example from last week with this generative tapestry we built. We created a framework of the grid, then in each cell we had some chance elements that would decide which pattern, which drawing would end up appearing in each cell. This is a similar concept. So we can extrapolate on top of this framework and then generate some really interesting results just by being a little bit creative. So let's do another example. I do want to keep this example though without deleting it, just this line, so that if you want, you can use it as a bit of a starting point for the code exercise this week. So what I'm going to do is I'm just going to remix my own project to start a new one and sort of say, okay, I'm going to save this for later. I'm just going to remix this project and give it a new name. All right, so this one, we're going to call it Dancing Square. So just as an example here, we're going to use a little bit of math to figure out, instead of a line here, I want to be able to draw, just to see what happens, just draw a square that's going to be sort of following this line here. But instead of a line, I'd like to be able to just draw a box. Okay. So the first thing I'm going to do is I'm going to find the midpoint between these two points, right? So we can do this in JavaScript. We can use the lerp function to find a distance between 2 points, not a distance, but to interpolate between 2 points. So here's an example of how this works. Let's call this mid-x. Okay, so we're going to say lerp. So lerp is a linear interpolation. So it says, if you give me one value, I'm going to say, and then another value, let's say we're going to interpolate between the x components, then you give it a float, and then that will give you the value that's sort of in between this one and that one using this proportion. So 0.5 is right in the middle, right? And if I did 0.2, it would be closer to x1, and if I did 0.9, it would be closer to x2. It's a little bit similar to map in that sense, but this is really about taking two endpoints and then figuring out values in between them. And we'll do the same thing with y. So we're going to interpolate between the two y values. And then the result here is going to be the midpoint between x1, y1 and x2, y2. So let's see if this works. We're going to draw a little circle at mid-x and mid-y. Okay. And I'm also going to disable the fill. And let's reduce the number of frames here. So you can see I have found the midpoint between my my two endpoints. Okay. So this is just another way of thinking about building on top of the framework. We can derive values from these 2 points by doing some basic calculations. Like we could figure out the distance between them. In fact, we're going to use this to set the size of our box, right? That would be the distance between the points. So let's do that. I'm going to say find the distance between the points. So the distance is not call it dist because this there's a function named dist. So we have a function named dist that says given 2 points. I'm going to be lazy here. I'm going to copy that. Given 2 pairs of coordinates, right? Given 2 points, just measure what's the distance between these 2 points. Okay? And then we could say let's set the size of the circle to be the distance. Okay? So now we have the circle is exactly the same size as the line. Okay? Or we could draw a rectangle. Now, if I draw a rectangle, the top left corner of the rectangle is always the 0, 0 point. So let's set rectangle mode to center. Okay. And let's slow down here the res and the number of frames so we can see a little bit better what's happening. So I'm drawing a rectangle here that's centered on the middle of my line and has the same size, right, as the distance between the 2 points. Now, as the last step, what we're going to do also is we're going to calculate the angle of this line, and then we're going to use that angle to just rotate our rectangle accordingly. So let's calculate the angle of the line. So calculating the angle is pretty straightforward. We have a we have a function we can use to do this called aton 2. So aton 2, don't remember now exactly what the parameters are, so I'm just going to look it up. Okay, so aton 2 takes the difference between the y coordinates of our points, and then the difference between the x coordinates of our points. And the kind of only weird thing about aton 2 has to kind of remember that always throws me off is that it takes the y values first as opposed to the x values. So we're going to say frame.y1 minus frame.y2, and then frame.x1 minus frame.x2. So calculate the angle between 2 points. And then now that we know this angle, we can apply a rotation to our box. Now, in order to rotate, we're going to have to make use of the translate and rotate functions, which means that in the beginning of each frame as we draw, we're going to use push to save the origin. Then we're going to use pop to restore the origin. Then we're going to translate. Once we found our mid x, mid y, we're going to translate there. We don't need to draw the line here. We're going to translate to the mid x, mid y point, which means this rectangle, we're only going to draw it at 0, 0 now. And then before we draw, we can apply the angle of rotation. Cool. So now we've just basically taken this framework we started with, which was 2 moving points, right? We then mapped a line onto these points to create this interesting little drawing machine. And then now in this one, I'm just going a little bit further by saying, okay, now we have these points here. Let's extract some additional information about these points, like where is the midpoint using lerp? What's the distance between them using dist? Or what's the angle between them using aton 2? These are some really useful tools that we're going to rely on at different times in this course when we try to make things happen visually. Get rid of this circle here. And then here we just draw like a little box just for fun. And then these controls we've created just give us some way to sort of alter the behavior of this drawing machine we've created. So, we can make the drawing, very faint, or have like very long trails. We can make it move really slowly by like, lowering the res, and then we're going to get some very different results. It's still the same framework of trying to like animate this box around using Perlin Noise, but we can create a variety of interesting textures just by messing around with these controls here. Or we could decide, maybe we want to have a shorter number of frames and just really increase the res here so that it moves more quickly, or creates like a longer trail. Anyways, we can play around with this. There's lots of different ways we can interpret that that framework, and we've given ourselves the tools here to explore some of the space of possibilities, okay? So that we can create some sometimes we'll stumble upon some combinations of settings that will give some really maybe pleasing or surprising results. Of course, we can close these controls if we want to. Now, here's a neat feature we can do with the GUI. If we find some interesting settings that we would like to remember or save, there's a way that we can add presets to these controls so that we can kind of save things that we've discovered and be able to recall them later. So we'll say GUI.remember our settings. And if we add this line here, this is going to add a menu on top of our controls, which disappears when we close it. We're going to open the settings, and we're going to check this box here that says automatically save values to local storage on exit. Okay. So that means that whatever settings we save here, they're going to be remembered, but just for our browser, not for necessarily other people viewing the same sketch. Okay. So we're going to make a new preset here. I'm going to call it slow. And then we're going to make a really slow variation on our animation, maybe with a long tail and a low alpha, just kind of creating these moving shapes here. We're going to save that preset, right? So now I can go back to, I can make a new preset if I want. I'm going to call it fast. Maybe this one has more frames and it's moving more quickly through the noise space. We're going to save that one. And if I refresh the sketch, notice that it remembered my presets. So now I can go to different sets of parameters that I saved. So that can be interesting as you're down the road, as we're creating these generative systems. We're going to give ourselves lots of parameters that we can tweak. And if we find interesting combinations using that GUI and this remember feature, we have kind of a built-in easy way to remember some of these interesting combinations as we go along. Okay, so that will be all for this week's lesson. I'm going to see you in the next video where I'm going to explain in a little bit more detail what I expect you to work on for the code exercise.